Hello, fifth graders. This is Mrs. Salyer from Roosevelt Elementary, and I'm going to be adding on to the lessons that you've had on area with Mrs. Sutherland and the lesson that you had on perimeter with Miss Johnson. Today's lesson is called Double or Not, and it is lesson 5.2.2. And your learning targets are that you can describe the relationship between two varying means different, quantities related by a rule. And in our case, we're going to be looking at the rule about the number of rows and perimeter. And your second learning target is I can use symbolic letter notation, such as using N for a number or X for a number, to represent the value of one varying quantity. So, I'd like for you to first look back at page 309 that you completed with Miss Sutherland. And in this particular activity, you were finding the total number of squares that made up different rows of 3 squares. So you discovered that if you had one row, you had 3 squares, and 2 rows, 6, 3, 9, so forth. But let's look at how many squares you had for some friendly numbers such as 5, 10, and 20. In 5 rows, you had 15 squares. In 10 rows, you had 30 squares. And in 20 rows, you had 60 squares. So I noticed that some of you found the total number of squares or area in a rectangle with 10 rows by doubling the number. For example, some of you were able to find the number of squares in 10 rows by doubling the number in 5 rows. Does that work? Is 30 double 15? Remember, doubling is the same as saying 15 plus 15 or 15 times 2. So, can you double the number of squares in 10 rows to find the number in 20 rows? Let's see if that works. If I double 30, I get 60. And when I looked at the number of squares that were in 20 rows, I did get 60. Do you think that I could double the number of squares in 20 rows to find the number in 40 rows? Well, let's think about that for just a moment. If I doubled 20, I would have 40. So if I doubled 60, which would be 60 times 2, I would have 120. So let's check it with our formula using the symbolic notation here for N standing for my number of rows and timesing it by 3. So if I had 40 rows and I timesed it by 3, my answer would be 120. So it did work that if I doubled the area for 20 rows, my answer to that, 120, would be the area for 40 rows. So, what happens with perimeter? If you recall, when Miss Johnson talked to you about perimeter, we know that area is the space that's covered inside the fence with squares, but perimeter is like the fence going around. And the perimeter with the 3 squares was 1, 2, 3, 4, 5, 6, 7, and 8. And with Miss Johnson, you completed your student activity page that I want you to get out. That would be page 311 that looks like this. As you were adding on to your rows, you were looking at the change that you had in perimeter. For example, in one row, you had a perimeter of 8, and that's just what we counted with our tiles here. 1, 2, 3, 4, 5, 6, 7, 8. Then you went on to discover how many you had in 2, 4, 3, so on and so forth. Then, if you will recall, Miss Johnson was writing her mathematical expression that she used to come up with these answers. And what she was doing was 2 times the number of rows, and you were adding 6. And that's a formula that you could use to find the perimeter based on the number of rows. So my question for you today